So for question 4 and 5 both, we're going to look at this particular student's response. It says, write the explicit rule for the sequence 1/2, 1, 2, and 4. And I like how this student went ahead and very clearly wrote out that the multiplier for this sequence is 2. As I move forward, I'm always doubling. And they also wrote out what the 0th term is. So if I'm at 1/2 and I want to go back to my 0th term, instead of multiplying by 2, I divide by 2. And if I check with my calculator, 1/2 divided by 1/2 divided by 2 is 1/4. So my 0th term is 1/4. And then when we put this all together, right, for the explicit equation, you can see here is my 0th term. T of n is equal to 1/4, and then times, here's my multiplier, 2 to the nth power. For the next one, we were asked to write a recursive definition for a sequence. In this sequence, we are clearly adding by 5, and I appreciate how that was clearly spelled out here. This is the generator for this sequence. Adding by 3, not by 5, adding 3 each time. And if you move backwards 1, the 0th term is 9. That's not actually needed here because we are writing the recursive definition. So it occurs to me now that there's one slight error with this answer. We should say that the first term is 12. So what this first thing should look like is that the first term in the sequence is the number 12, right? So you need to tell us what the first term is. And then the next part is the recursive part. And this is exactly how I read this. To get to the next term in the sequence, right, the t of n plus 1, the one after the nth term, to get to the next term, you take the term that you're at and you increase it by 3. So together, this says, hey, start at the number 12, and then to go to another term, add 3. To go to another term, add 3. So it tells you where to begin, and it tells you how to get more terms. All right, that's it for questions both 4 and 5.